Good morning, students. I hope you all are doing great and have had a good weekend. You all can see my shared screen, right? So today there is no do now activity. I'll start right off with today's class. Okay. So today we will be reviewing solving exponential and logarithmic equations. If you remember, we already spent a lot of time on that, but since you're going to have STAR exam by the end of this week on 13th, so it's a good time we go over these one more time and have a good problem solving practice before we have the exam. So to start with, there are three rules which I want you to note down and keep in mind. Uh, Also, you have your own class assignment posted to the as a CAMI document to the Google Classroom, so you can open that and do your work on that. So first is the definition of a log. Okay, so if you see here, we have an exponential term. B is the base, x is the exponent or power, and that is equal to something n. Then we can change that into the log. So if we on one side we have the exponential relationship, the same relationship if we express as a logarithmic equation, it's going to look like log with a base b of n will be equal to x. So x basically is the, in the case of a log, x is the exponent of an exponential term. So if you remember this relationship, it will help you because you may need to switch from an exponential expression to the logarithmic expression, or the other way around. You may have a logarithmic expression and you change that to an exponential term. Second thing is a change of base properties. So log, we know that we may have different base, like in exponents, we may have 2 as a base, 5 as a base, 10 we know as the common base, and e, the Euler's number. So when we change that into log, the same base appears over there. So if we need to change the base of the log, then this is the formula that we apply. Log base a of x, a is the base, it could be anything, is equal to log base b of x. B is the base we want to change it to from log base a. Okay, so if we want to change log from base a to base b, then we will simply write log b of x divided by log b of a, the initial base we had for the log. So this is the second important property we need to keep in mind, and it is called change of base property. And then the third is called the power law rule. So if you have a log and inside the log you have an exponent, then this power can come out and you can continue on with the log. So log base b x with the power of p is the same as p multiplied with log base b of x. So the power would simply come outside the log term. Two more important logs among all kinds are the ones we have on our calculator. We use very often. One is called the common log. It is based on 10. So 10 base something, you can have that as a log of base 10. And then the natural logarithm, which we write as ln, and it has a base of e, which is the Euler's number, and it has a value of 2.718. And these are the two more common logarithm bases. So we, most of the time, whenever we have a log in any other base, we change that to one of these and we just solve it. Okay. Now, if you have problems like these are the few points that you should keep in mind while tackling such problems. First, you read the problem and you may need to annotate key information if you have a table or graph. So you should thoroughly read it, take your time, and then note down important things that you see within the words statement or the graph or the table. Use inverse operations to solve for or isolate the variable. So most of the time you need to solve for x or whatever variable you're given. So you need to make sure you have your variable on one side and everything else goes to the other side. Now in the third bullet, it says if you have an exponential equation, you can either rewrite using logs and then apply change of base property, or take the log of both sides and apply the power rule. So we will see how we do that. Similarly, when you are solving logarithmic equations, you will rewrite the equation to exponential form and then use exponents and inverse operations to solve it. So as you see, log and exponents are inverse functions. So if you are working on a logarithmic problem, to get rid of the log, you will use the exponents. And if you are working on the exponential problems, you will apply the log to get rid of the exponents. Okay. Always check your answer. Whatever value you get, what is your final answer, you substitute or enter into the calculator and verify that your answer is correct. So in mathematics, this is the fun and the beautiful part, that whatever you get in the end, you can verify, you can confirm that it is the right answer. So moving on to the teacher's model. Now you see the first problem, it's a logarithmic problem. And what is the base of this log here? Can anyone tell me what is the base of this log? Isaiah, what do you think is the base of this log? Yes, Jamorian, good. It's 4. Very nice. So when you look for the base, it's the small subscript written just next to the log. So it's 4 here. By the way, if there is nothing written here and we have just the log, what is the base in that case? Anyone who would like to answer? My question is, if you have a log expression, but you don't see any base written, it's just log of something, what is the base? Okay, Osiris. Because you may see a problem where there is a log, but there is no base. So if you don't know what is the base in that case, you may have trouble solving that problem. Valeria, what do you think?
I'm not sure, but is it like 1 or 0?
It should be 10. Yes, Valeria, thank you. So whenever you see a log with no base mentioned, it's naturally, automatically, you should think that it's a log of with base 10. Okay. All right. And if you have ln as log natural, what is the base of that log? Jamar, what do you think?
Sorry, may you repeat that?
Yeah, if you see log as ln, which is log natural, what will be the base of that log?
Log ln?
Log is you see as written as ln, log natural. So what is the base of that log?
If it was log natural, would it be ES equals N?
It should be E. Very good. Yes, E is the Euler's number. So log natural means you have a base of E, and E has a value of 2.718. Okay, very good, Jamar. So these are the few things I just wanted to confirm. We just read these things above. If you look at here, it says common log that you have base 10. Natural log, ln, you have base E. So very good. Now in this first problem, you see the solution already there, and I left it as it is because I wanted you to read through the steps as well and see how we progress when we solve these problems.
Dr. Islam,
Yes, Miss Williams.
you said the E is 2.78?
718.
718, okay.
Yeah. Okay, so now when you look at these 4 steps, first in the first step, you want to get rid of the log. So what you do is you change that to an exponent form. So what you do is you take this 4 to the other side, that becomes the base, 3 becomes the power or the exponent, and then you write 3x negative 8 without the log. So you got rid of the log in the first step. and it says rewrite in exponential form. So 4 exponent 3 is simply 4 times 4 times 4, that is 64. And then you say evaluate, that means solve for x or simplify. So simplification again means the same thing. You take this negative 8 to the other side, it becomes 72. You divide both sides by 3, you get x equals 24. Now, when we want to confirm if we got the right answer, we'll take this 24 and plug it in here. 24 times 3 is 72. 72 negative 8 is 64. When I have 4 power 3, that is 64. Okay, so 4 exponent 3 will be 64. So my answer is correct. Okay, so please, you have it in your own copy, but if you want to if you feel like writing down some notes, I think it's a good idea. Second problem is an exponential problem. So it's now the other opposite function, the inverse. We had the logarithmic equation first, now we have the exponential equation. And you can see here in this, I have it listed as method 1 or method 2. So looking at each method one by one, in the first case, you apply log on both sides. So you will have, first of all, you get rid of this 3 from here. So you divide both sides by 3. So 96 changes to 32. Then you take the log on both sides. So it's going to be x log base 4 of 4, that is 1, is equal to log base 4 of 32. So now this is log base 4, and you need to change that into a common log base 10. So it's a change of base step, the second one. So when you change that from log base 4 to log base 10, it becomes log of 32 divided by log of 4. So if you recall, on the first page, we had the same equation where you change from log from base A to base B, right? So all you do is you take the same log of same number, log of 32, and then you take the log of the base that was 4, so log of 4. So log 32, log 4, you can always use your calculator to solve it, and you get to your final answer. On the other hand, on the method 2, again, you had 3 taken care of. You divide by 3 on both sides. And when you take the log, then you have log 4 exponent x is equal to log 32. X will come out. X log of 4 is equal to log of 32. So this is, in this case, if you notice, we didn't take log of base 4. We took the log base 10. So you don't see any subscript next to the log. So that means it's not log base 10, it's log base 4. Sorry, log base 10, it's not log base 4. And then when you have x is equal to this, then in the next step, you divide both sides by log of 4. So you get the same expression as this one. X is equal to log 32 divided by log of 4. So I'll give you a few seconds to look at these two methods very closely. And depending on whatever suits you, whatever you're more comfortable with, you can use the method. You can either directly go with the log base 10 and then solve it, or you can go with the log base of 4 and then change the base using the expression. So take a few seconds to look at this problem properly so you get some idea. Okay, I guess I can move on to the next problem now. So let's look at the next problem. And it says find a solution to the equation 1500 times 1.04 for x is equal to 3000. Okay, so now again you want to isolate this term that has x, because x is what you need to find out eventually. So you divide both sides by 1500, so you will get 1.04 exponent of x is equal to 2. Now once you have this expression, you can either take log base 1.04 like I did. So x is equal to log base 1.04 upon 2 of 2, and then I change the base from change the base from 1.04 to base 10. So log of 2 divided by log of 1.04 is equal to 17.7. If I wanted to go directly, instead of changing the base, if I want to write, for example, this thing, I'm going to just do it the other way. So here, what I do is I take x outside, and then I write log of, now I'm not taking log with base 1.04, rather I am taking this as log of base 10. 1.04 is equal to log of 2. Okay, so in this case, in the next step, when I divide both sides with log of 1.04, I get the same expression. X is equal to log of 2 divided by log of 1.04. I use my calculator to find these logs, and then I get my final answer, 17.7. Okay, so this is how you do. It's again an example of exponential problem that you solve for x. Okay, now I'll do example number 4, and it says the growth of a population of an elk herd in the Davis Mountains can be modeled by the exponential growth equation below. And we have an exponential expression where p is the number or population of elk at time x. Randy would like to rewrite the equation in logarithmic form and solve it for x. Which of the following equations would be correct? So what I'm going to do now, I'm going to copy this expression. I read out the statement to you guys, and now I'll simply open a Jamboard, a whiteboard, and then I'll do it over there. So the link is in the chat, and I will also share it. I will start sharing that screen if some of you have issues looking at that. Okay, so this is the expression, and then these are the options. Let me write down the 4 options as well. Okay, so here now let's solve it. Okay, so first of all, we have p equals 50. In this case we have the base 2, right? So 2 exponent x upon 10. Now what will I do first of all? Can someone tell me, please? What is the first step you need to take when you solve such a problem? Come on, someone should come up with an answer. You need to solve for x. So the first thing you would do is you will isolate your term involving x. Okay, so in this case, what we see is that 50, right? So that 50 we divide by on both sides. So we divide to get rid of this 50 from here. So this and this. So when we do that, now we have only 2 exponent x over 10. So 2 exponent x over 10 is equal to p over upon 50. Well, since some of you may get confused with the change of base thing, so I'll just go ahead and take the log with the base 10. So if I do that, taking log on both sides, I will have x upon 10, and then I will have log of 2. So I'm taking the log on both sides, and then because of the power law, I took x upon 10 outside, and then here I can write log of p over 50. Okay, so now it's a simple log, which is log base 10. I don't have to worry about changing the base. Okay, so once I get to this point, now what do I need to do? So here, once I have come this far, this 10 I need to get rid of. So I multiply both sides by 10. And when you multiply by 10, make sure it is outside the log. It doesn't go inside because we are just multiplying with 10. So this 10 cancels out. And the second thing we do is we also want to get rid of this log 2 from here. So we divide by log of 2. So when we do that, then we do the same thing on both sides. So here we also have log of 2. Okay, so now I only have x on one side. So x is equal to 10 log of p upon 50 divided by log of 2. Okay, so I'm just crammed for space. So p upon 50 divided by log of 2. When you look at your answer and you want to compare with the given choices, then you see here 10 log p upon 50 upon log of 2. You notice that this is your correct answer. Okay, so this is basically the, yeah, I didn't write the letters, but this is how you solve it. So I want you to, when you're doing the work on your personal copy of the class assignment, write down these steps. Okay, don't just pick the right answer, crossing out the wrong answers. Write down this step as well. Okay, I'll give you a few seconds before I move on to do the next problem. Okay, now let's try to do the next problem. Okay, I'll copy the next problem and we'll solve it. So this is example 5 of the teacher's model, and this is an exponential equation that you need to solve. And this time we don't have the variable x, instead we have the variable p. Okay, so it doesn't matter, we know that we need to solve for the variable whatever it is. If it's not x, it can be any letter, so that's not very critical thing. And here we are given the 4 possible choices. Okay, so what I do is I think I did it the other day with you guys, but I'm just doing it. Maybe some of you are not here or you didn't understand. So when we have such a problem, p squared times p power 4. And outside the parentheses, we have exponent 1 upon 3 plus 5 is equal to 13. So when we want to solve this problem, what is our first step? Please tell me. I see some response in the chat. Let me check that. Okay. I see Ms. Williams' response. So basically, what do you do when you solve this problem? What will be the first step? The more you are involved, you are engaged in the class, try to answer. Yes, Diomar, thank you so much. I see that. Move the 5 to the 13. That's exactly what I wanted to hear. So what you do is you just take this 5 to the other side, and for that you need to subtract from both sides. So when you do that, so you will get 13 negative 5, right? And that is going to be 8. So very good. Now, the other thing we do, once we have this 5 taken care of, we can also see P4 and P2, right? And they're multiplying. When they're multiplying, what happens to the exponents? When you multiply P squared with P power 4, yes, I see your response, Valeria. The powers add. Very good. So you will have P power 6. Okay. When you have P power 6 and you have P power 1 upon 3, what happens to the powers? This time, they multiply. Okay. So see the difference when you need to multiply the powers, when you need to add the powers. When you have powers with the same base, here we had P power 2 and P power 4. Then we added the powers. But when we have P only and 2 powers, we multiply the powers. So 3 2 times 2 is 6. So P squared is equal to 8. Now what we do is we have the exponential expression. We take the log. So we will have 2 log of P is equal to log of 8. Wait a minute. Is this, in this particular case, when I look at the possible answers, I see that I have a log with the base P. So I should not actually have log with the base 10 here. Okay, I will just go with the log base P. So if I do that, let's see what I get. Okay, so this step, I could go on and do this step, but there's no point because it doesn't lead me to one of the answers. So instead, I will say log base P of P squared is equal to log base P of 8. Okay, so now log base P of 8. And then 2 comes out, log P of P is 1. So then you will have 2 is equal to log base P of 8. Okay, so this is your final answer. And when you compare here, this answer is the same as this answer. Okay, so your option C is correct. Okay, someone could say that if you don't want to change this to the log form, in this particular case, from this step, you could just take the square root of both sides. So you will have P equals square root of 8, and 8 is 4 times 2. So you could write this as 2 square root of 2. But now you look at the possible choices, your answer is given in the form of a log, so you will have to take the log on both sides. Okay, Osiris, no problem. So make a note of this, and I will give me a minute and I'll get back to you and continue on from here. Okay. Okay, let's do example number 6 now. Okay, and these kind of problems you can see very often, and you should have a good confidence of solving these problems. Okay, the equation y equals 50 times 1.05 exponent x models the growth of a mule deer. Okay, I did this problem last time, so I'm not gonna do it. I'm just gonna solve it mathematically. Okay, y equals 50 times 1.05 times x. So this is the exponential equation, and the four choices we are given are in terms of the years. Okay, so I just want to keep these choices in front so that I know when I solve it. So here you need to find x, and y is given. Y is the population of the deer, and it says when it reaches 1500. What year will it reach 1500? So y is 1500. So you write 1500 is equal to 50 times 1.05 exponent x. What do you do first? What is your first step? Can someone please tell me? So you have to divide it by 50 on both sides. Okay, so you divide by 50 and you get rid of the 50. You want to isolate this term which has x. Yes, very good. I see your response, Jamar. So this, I have 1.05 to the power x is equal to 30. Okay, so then you just take the log on both sides. So you will have x log of 1.05 is equal to log of 30. Okay, so now you didn't take the log of with base 1.05, you take directly the log with base 10. So I don't want to make you go through this change of base thing, because that may confuse you. You can just take the direct log, so you don't have to change the base later on. So then x is simply log of 30 divided by log of 1.05. Okay, so log of 30. Remember, you do not divide 30 by 1.05. You take the log of both, okay, and then solve it. So when you do that, you use your calculator to find log of 30. and log of 1.05. And then once you solve it, you get something around 69.7. Okay, so 69.7. I had it. Let me check. I had it written somewhere. Yeah, 69.7. So that is almost 70. So this started when the population was 50 in 2015. So 2015 you add 69.7 years, okay, which is basically 70 roughly. So you have 2085. Okay, so 2085 is your answer. It's the year when the population of your deer will become 1500 for the first time. Okay, so make a note of it, and we'll continue on with the next problem in a few seconds. Okay. Do you have any questions so far? Anything you didn't understand properly? But these problems, they are primarily about practice. So when you practice them, you will get better with time. Okay, so let's do another problem. This is again a log equation. Log natural of 2x plus 4 upon 5 is equal to 3. And we need to solve it for x. And then there are 4 choices given. So I will copy those 4 choices as well. All right, so when you solve such a problem, now what is your first step? Jose, what do you think?
Don't we have to get rid of the fraction inside the parentheses, or like simplify the fraction?
Before we simplify the fraction, you see the log here, ln, log natural, right?
Oh, yeah.
Can we get rid of that log?
Yes.
How? Yes, you see the hint we got from Mia? It says exponent. Log and exponent are inverse. Yes, Valerie also says the same thing. So Hosea, when you want to get rid of your log, you take the exponent. Okay? So if you look at the first page of your class assignment, it says how log and exponent are related. So basically, log natural is simply, it's a simple way of writing log with base e. Okay, so log natural is the same as log with the base e. When you want to change it, the base goes to the other side, and the whatever is on the other side becomes the exponent. So first of all, you will have e exponent 3, and here you will have 2x plus 4 upon 5. You don't have the log anymore. So 2x plus 4 upon 5 is equal to e power 3. Now, if someone doesn't know this step, and I'm being straightforward, if you don't know this step, forget about solving this problem. Remember, whenever you have this log expression, you want to change to the exponent form, you find out what's the base of this log, take it to the other side, whatever is here becomes the power, and then you get rid of your log. So e exponent 3 comes here and log disappears from here. Now you solve it further by multiplying with 5 on both sides, because you want to get rid of this 5 from the denominator. So 2x plus 4 is equal to 5e power 3. Okay, 5e cubed. Then you get rid of the 4 from both sides, so you subtract 4, you get negative 4 here, and then you divide by 2, so this cancels out. Then you divide by 2, then you divide with the same 2 on the other side. So you end up with 5 upon 2 e cube negative 2. Now, if you solve this far and you had an answer in terms of e, you would be good enough. You would be all done. But if not, you have a number here, you have a value here, then you need to write e as some number. We know that e is 2.718. Okay, so when we take that value of e and we take the cube and then we solve it, then we have this number 48.2. Okay, so this is how you solve it. You change first your log to an exponential form, then you solve for x. So we isolate, we have x on one side, all the terms, expressions on the other side, and then we end up with the final answer. So these are the few things you should know. You should always remember log natural, ln is basically log with a base of e. E is the Euler's number. It has a value of 2.718. And how to switch from logarithmic expression to the exponential expression. Okay, now let's do the next problem before I ask you to do your independent practice problems. So this is again a log problem. And what is the base of this log? Can anyone tell me what is the base of this log? 2. Very good, Osiris. This is a log with base 2. So first of all, thank you, we divide by 5 because we want to get rid of this 5 next to our log term. So we divide by 5 on both sides. So we end up with log base 2 of x plus 3. 20 divided by 5 is 4. So this is equal to 4. What do we do next? Can anyone tell me what do we do next? We simply get rid of the log. We change it to an exponential form. So we take this 2 to the other side. And 4 becomes the power. So 2 power 4. And then we write x plus 3 here. Yes, thank you, Valeria. So 2 power 4 is 16. So that is equal to 16. 2 power 4 is just 2 multiplied by with itself 4 times. So then we subtract 3 from both sides, and we have x is equal to 13. So this is our answer. This particular question didn't have any multiple choice answers. to pick from. You need to just solve it, and when you solve it, this is what you get. Okay. There is another problem, problem number 9 of the teacher's model, but I will not do that now. I'll stop here, and for the next 25 minutes rather, I want you to work on the independent practice problems. So please go ahead and start working on your independent practice problems, and whenever you have an answer to a problem, share that with us in the chat, so we can compare, and I will randomly pick you after a few minutes to solve some of these problems with me. Okay, so go ahead and start working on your independent practice now.